Good afternoon, everyone. Welcome to the Construct Innovate webinar series on digital construction technologies. My name is Jamie Goggins and I'm co-director of Construct Innovate. Construct Innovate is Ireland's National Research Centre for Construction Technology and Innovation. This is an 8-part series. This week, the focus is on simulations for better performance. We've got 3 speakers again this week. Really looking forward to these 3 presentations. So our first presenter is going to be Gavin Duffy, who's Director of RealSim, and he's going to speak about achieving efficient design and successful planning outcomes using digital twins. Then we have Professor Eoghan Clifford, who's Head of Civil Engineering at the University of Galway, and he's going to speak about innovations in construction and operation of wastewater treatment facilities. Then Robert Moore, who's Project Lead at Build Digital, is going to speak about information requirements to drive simulation and other case studies. So we're going to have the 3 presentations, each of them will be about 15 minutes each. 10 to 15 minutes each, and then we will deal with the questions and answers at the very end. So if you've got any questions for any of our speakers as they're going through, please post your questions within the Q&A function that you'll see at the bottom of your screen. And then, as I said, we'll take all those questions at the very end. Okay, so without further ado, I'm going to hand over to our first speaker, Gavin Duffy, who's Director of RealSim, and is going to talk about some cool digital twins that they've developed. So over to you, Gavin.
So yeah, we're actually based in, I was nearly going to say NUI Galway, so getting used to the name change, University of Galway as well. And we're a private business that's been involved in wide area digital twins for planning assessment for now on. I've been working in the area for almost 20 years, but I guess it's really only become more cognizant in general planning spheres in the last few years. We're looking at here is a digital twin of Sandyford in Dunleary Rathdown that we built last year, and it's one of our more advanced ones, and I can show maybe a little bit of that later. So essentially what we create are easy to use geospatial digital twins for planning communication. This is a screenshot from Dublin City University digital campus twin we created for the Estates Office, and we're hoping it's going to be leveraged by the Insight Centre there to add as a sort of a sandbox testing platform for various campus simulations as well. So the term digital twin is quite commonly used. I would probably say too commonly used. We would see a lot of the things that are assigned to be digital twins as sort of more process simulation. We take a very literal interpretation of the term twin, which means something that looks exactly like something else. And in the digital twin world, that would be a digital version of something physical. So you're seeing here a picture of our area line, and you know, here we've got the digital version of that. What makes but that's not just the geometry model. You also need a software or rendering platform to display that information in real time at ideally 60 frames a second. And then the intelligence that's added to that is the geospatial data. And of course, that rendering platform can also have various analysis and ideally be able to hook into other analysis, because there's no one platform is going to be able to tell everything. So ideally, the way we see it is you have a dashboard that can hook into whether it's energy analysis or transport simulation, and essentially the digital twin is the display dashboard for all that information, and makes that other information far more accessible to non-technical as well as the technical people who essentially shape our environment, from planners, architects, engineers. So it's really all about accessible data for more efficient and informed planning decisions. And I would argue that our planning system is too opinion-led rather than data-led. We're the only company in Ireland that's currently managing a 3D planning assessment system. We've been doing that for actually 12 years now. And we've got almost 30,000 buildings represented across the island. It covers 120 square kilometers. It's been used for, at this stage, almost 900 architectural planning assessments, and is used by over 200 architects. So every new building over 200 square meters goes through our office in Galway. and we just send it back to Jersey, and they analyze that model in a desktop and web viewer online, so you can see unlimited perspectives, and they can make decisions far faster than is possible than our current, so we say, static visualization system in Ireland. The process flows like this. Spatial fidelity is really, really important. You can't present something that is not spatially accurate, so the underlying mapping is very, very important. Traditionally, we've used sort of wide area, the best available and most current mapping from traditional aircraft, which produces when normal surveys generally acquire stereo imagery, which allows you to essentially locate in 3D space every single pixel when you've got 2 or more photographs of a point. The accuracy of that depends on the ground pixel resolution. So, you know, a 20 centimeter per pixel aircraft survey will give you no better than a 50 centimeter sort of position in space. You get to drones, which are now acquiring 1 to 2 centimeter per pixel imagery, then you've got a far higher resolution. So now translating these dense point clouds into accessible data is one of our so we say skill sets. You know, that doesn't necessarily easily go into any architectural software. You don't need, you know, 1,000 or 1,000,000 points to define a flat roof. So we take that information, we just model light CAD models, superimpose on our own photography, and that's the key, is making this data light and accessible with a known accuracy. But I'll go through that a little bit further now. So this is sort of a view of a point cloud model of a building in DCU. This is the CAD version of it, a lot lighter. We've just made it photorealistic by adding on ground photography, and then this goes into accessible tiles that are DXF, FBX, IFC, various formats which are not tied to any specific software. So they can go into any architectural model, which is really important. If I just come back very, very quickly, this bit at the bottom here, here's our architect with his hard hat and compass. The key is architects and engineers are creating data all the time. Problem is, it's locked into their computers. You know, what gets sent for the general public are 2D views, 2D plans. How do we unlock that data and put it into existing digital twins? And that's the key to creating efficient data-led planning and harnessing the power of a digital twin, is creating that information exchange. And I know, say, Robert will talk more about data later in his talk. So information exchange, we provide not just the modeling, but also the rendering software. And again, it's built on game engine technology, which is far more appropriate for essentially rendering in real time large data sets. It has unlimited perspectives, create new buildings. And again, we're talking to people who are involved in sort of measuring carbon capture to integrate it into our desktop. Just some examples. We did some work with Mayo County Council, so it doesn't have to be restricted to, you know, big cities. This is a small village in rural Mayo, looking to put a new greenway through the town. Traditionally, you know, there would have been just a few CGIs and CAD plans were difficult to interpret. We essentially gave them an interactive 3D model so they could walk it with the local community, and they essentially did that. They did it, and there was an iterative design process with public consultation where they literally went door to door, and things like where the drop curve was put, where lampposts were put, small things were adjusted based on the fact that they could see things from every perspective. And in the end, they got 100% community backing from all the local landowners on this. And now the greenway is built. So that was done over the space of 12 months from that consultation to getting shovel ready and getting it built. Another small town one was a place I actually grew up in Laois, Mount Rath. Again, the design implemented after extensive community consultation. That's led to the establishment of a town team to drive regeneration. and they were recently successful with a 250K funding application, and a lot of the visuals and community support was driven from the interaction with the digital twin, which was online. And then I guess our first was, and this project actually recently got the Top E Government Award just in the start of COVID 2020. Fingal commissioned us to build a VR version of their proposed regeneration plan for the harbour area in Balbriggan. This is the first web viewer, we believe, for any local authority, and it has gone through 3 iterations. Final design agreed, public fund feedback generally was supportive of the final iteration, and has now received funding and construction has started. I'm just going to this is Sandyford, where we're basically have incorporated land use layers, building height, planning applications. There's a lot more information you can add to these. There's another screenshot of Sandyford, and I'm just going to whizzing through. These links can be shared. These are currently live web links. So the big advance for us over the last couple of years to be able to make these available, not just on desktop, but online. So you can now view these in interactive 3D through a browser. Just to kind of show you what that looks like. I have running here in the background. This is something we'll be launching shortly. So not many people have actually seen this, but this is our 3D model of Cork. Cork City, utilizing one of the best airborne surveys for any city in Ireland at the moment. 5 centimeter per pixel, so almost drone resolution. And just very, very quickly look at some of the things we've got sort of our daytime shadows, even seasonally responsive trees to change in winter, different cloud and weather settings. More than likely we can. So it's, when we're looking at these nice CGIs, it's always under particularly just happy blue skies. And again, everything is geospatially accurate. If I put in our height tool here, you can see the height above ground is 0. As soon as I put it up, move my cursor, I can see the height of any point in any building. I can see the distance between any 2 points, or I can measure a polygon area as well, and it gives us the area. And crucially, we can then start to incorporate lots of layers in terms of building heights, land development zones, and what we've been working on recently is essentially incorporating all the CIS as a collaboration we have with Construction Information Services Ireland, which somebody might be familiar with, who essentially collate all the planning data. Now they have locations and where these things are. We've actually taken the 2D files, converted them all to 3D, and this is one of the few platforms that you can actually see the future development, approved developments in Cork, including ones that are being that are currently in construction, like Horgan's Quay here. So if you can consider that we know that almost 80% of planning objections are due to people complaining about potential lines of sight, we can go to any house and literally see from their perspective, what the views will be like, where the shadows will fall, and to be able to definitively use a data-led analysis on potential complaints is something that digital twins, in terms of a solution, can offer. Okay, I think that's me reaching the 15 minutes now. Thanks for your time, and happy to hand over to Sinead.
Brilliant. Thanks, Gavin. That's fantastic. I suppose showing the power there of that. We think about in the past, we think about these models, they just seem huge, like to be able to do anything with them and that, but to get to a stage where you have now got these CGI level digital models that are web-based that you can interact with, and you can get some very useful information in different layers of that. And as you said, having like a data-led analysis and data-led decisions made should be very, very powerful in there. Okay, so I'm going to hand over to our next speaker, Professor Eoghan Clifford, who's going to talk about innovation in construction operation of wastewater treatment facilities. And if you have any questions for Gavin or any of our further speakers, then please do put them in the Q&A function at the bottom of the screen. So over to you, Eoghan.
Yeah, thanks for the opportunity to speak today. And I'm going to talk maybe about something a little bit different, maybe not as visually appealing, and that's, I suppose, the use of data in control and operation of wastewater treatment plants and how it links with simulation as well. So just a bit of background, I guess internationally, the water wastewater sector is, I suppose, under a lot of pressure. Things like climate change, aging infrastructure, and regulatory pressure is causing, I suppose, putting pressure on the existing infrastructure. And a lot of the questions are around whether we need to build more infrastructure and how much, and also how much more we can get out of the existing infrastructure. And there's kind of a trade-off of challenges happening at the moment. And one side, utilities are being asked to reduce costs, energy, resource consumption, and more recently emissions, which is actually going to be one of their biggest challenges, in particular nitrous oxide. On the other side, they're being asked, I suppose, to meet the climate change resilience targets, which might include the increasing volumes of stormwater to come into sewer lines, things like population growth, economic growth, and also stipulations, for example, under the new Urban Wastewater Treatment Directive, which has more stringent stipulations around nitrogen, phosphorus removal. And those on the right-hand side do, to some extent, mean that with existing practices, emissions will increase from wastewater treatment plants, costs will increase, and energy and resource consumption will increase. So the question is, how do we try and trade off these two or meet regulation while we reduce emissions? So one of the solutions will be data and simulation. And I'm going to give some examples, maybe a bit of background as to how it's used in wastewater treatment and some examples of some projects that we have looked at. So firstly, the kind of data we can collect from wastewater treatment plant is there's quite a lot of data we can collect. It's quite different types of data, everything from electricity consumption to the wastewater characteristics, things like nitrogen, organic carbon, chemical dosing in the system, dissolved oxygen, people might be familiar with that. Water use within the system, what are your influent flows? So there's lots of different types of data parameters. And we use a combination of different types of sensors, laboratory analysis, and a lot of this data should be put up on SCADA systems, and it is done to a certain extent, depending on the wastewater treatment plant. The data itself is quite varied in nature. So in some cases, the data might be only at a weekly or monthly level. Things like regulatory data for some wastewater treatment plants, believe it or not, in fact, for quite a lot, there's only influent and effluent data available at that type of frequency. Things like purchasing data and operator measurements are often taken at infrequent data or intervals, particularly for small wastewater treatment plants. And daily data, things like, for example, at larger plants, lab-based analysis of water chemistry, aggregated data of flows, energy, etc., and things like the actual health of the system, variables to tell us about how healthy the biomass or the sludge is. And then, of course, we have data which can be collected at the frequency of seconds or minutes, things like inline sensors measuring dissolved oxygen, energy, ammonium, pH, oxidation reduction potential, and other parameters like that. So part of the challenge is how to integrate these various different types of data. In terms of leveraging the data, I suppose there are three high-level types of options that we use. On the left-hand side, you have more the simulation type options, which are based on a physical understanding and knowledge of the system and try and predict how our system will respond to various changes and how we could maybe optimize the design. And this white box modeling is particularly useful for training and also for process simulation and particular scenario analysis. It may be less useful for day-to-day control of wastewater treatment plants, but definitely will allow us to run a lot of different scenarios around their operation and improve design. And then you move over to the right-hand side where you have black box or data-led approaches, where really what's going on in the middle, we mightn't understand a whole lot about what's going on in the middle, but we're trying to use the data that's coming into the plant to try and predict something about what's happening in the plant and what might come out of the wastewater treatment plant. That can be useful for real-time process control, for fault detection and diagnosis, but often doesn't have a lot of explanatory power. And in the middle, you have grey box approaches, which try and mix these two together. And it's probably a combination of all this that will be used in the wastewater sector and is being used increasingly in the wastewater sector. So what has been done to date? There are some examples going back even to 1996, where some of the first examples, particularly in Denmark, were, I suppose, implemented in real-time control of wastewater treatment systems with limited success. In the last number of years, there has been a little bit more implementation with some larger scale case studies from countries like Spain, Italy, Denmark, and more recently in the last year or two, in particular in Denmark, for example, and the Netherlands, there has been, I suppose, a much more rapid uptake of real-time control in wastewater treatment plants, but it has normally been limited to 1 or 2 case studies, and definitely limited to larger treatment plants where you have more operators available on site. And maybe what has limited some of this implementation is particular issues around the data and how we use it. And there's a lot of challenges in the wastewater sector around the type of data we collect and how we can go on and use it. So something as simple as missing data, for example, when we look at wastewater treatment plants, in some cases up to 50% of the data points can actually just be missing for various reasons from the databases. Instrumentation fouling is a key problem. And of course, if the instrumentation is fouled, the data that you're getting is effectively useless. And so the actual upkeep of instrumentation is a big issue in wastewater treatment plants. Things like data transfer, data errors, maintenance and capital costs of data collection systems, their reliability and complexity is another issue that has, I suppose, reduced the uptake. And then in terms of using the data, there's often a very complex relationships between parameters. So these are effectively biochemical systems. So they are a little bit somewhat chaotic. And the relationships between parameters, while we do understand it at a higher level, it is sometimes difficult to actually, from a data perspective, to actually understand that fully. So there's a lot of challenges in implementation of this in the field. So moving on to some of the work that we have done. So in general, we started actually looking at small scale wastewater treatment plants because I suppose they are often more problematic in trying to implement these systems. And we did some projects with Malloy Precast Engineering where we looked at systems that were working up to maybe 100 population equivalent. So treating for a collection of small houses or small villages. And our ideas here were, could we implement real-time data control on site using very basic PLCs that are sufficient to turn off and on aerators, pumps, do a little bit of data analysis on board, but not much more complex than that. And what are the minimum data sets that we could collect that will be useful to control the plants? So what we actually found in these cases was that actually not measuring the contaminants of interest was the most important. So things like nitrogen and organic carbon tend to be the parameters that are regulated, but in fact, they are actually quite difficult to measure sometimes, and also the sensors that measure them are prone to fouling. Whereas we found using measuring other parameters such as pH and ORP, while they are surrogate parameters, could tell us a lot about the control of the system. In this particular project, we controlled SBR, so sequencing batch reactor systems. People may or may not be familiar with them at a small scale, basically using measurements from pH and ORP probes only. What we were trying to do is switch on and off pumps and aerators, shorten cycle times in order to achieve more effective treatment. And we were able to show an energy reduction of 43% in these systems with a cycle reduction of up to 60%. And that's very significant because reducing the length of cycles in these types of wastewater treatment plants effectively increases their capacity in the system itself. So if you can shorten the cycle, the treatment plant can actually treat more in the same amount of time while still reducing energy costs. In all these cases, compliance is one area that we have as an absolute area that we must adhere to. So we build that into our control systems. Other systems we developed, one was a research system in Tuam in County Galway, and based on the same technology, another system in Moneygall, which is actually operational in County Offaly. In both of these cases, the systems were again controlled in real time. The key controlling parameters were using dissolved oxygen, pH, and ORP to control things like pumping cycles, aeration cycles, and various other parameters. I'm happy to answer questions on the details of how we implemented that, but again, you could see very significant reductions in performance benefits from doing this if you were able to leverage the data while you were remaining within compliance. So for example, for these two treatment systems, the average costs equated for running the treatment systems while in compliance for such small scale systems to about €3 per person per year in electricity costs, which is for any scale of system, particularly small scale systems, extremely efficient. And again, a lot of that was due to reductions in the amount of length of time which we ran mechanical equipment. So where we're kind of going with this is work we had done over the last maybe 10 years, but where we're going with that in new projects is trying to implement the emissions factor into this. So in those projects, our goals were to meet compliance and reduce costs, and if we could increase the capacity of the system, so intensify the infrastructure. But now we're trying to bring the whole emissions issue into it, and one of the key things you want to look at there is control of nitrous oxide. So what data can we leverage from the treatment plants such that we can actually still meet our emissions, our energy targets, our treatment targets, but at the same time control the system to actually reduce the nitrous oxide emissions. So in this particular project, we're working with Warren Burke on a number of full-scale treatment facilities. It will be the first time in Ireland that treatment facilities have been instrumented for measurement of nitrous oxide. Alongside that, we will measure a lot of other parameters such as ammonium, solids concentrations in the tanks, other nitrogen and carbon parameters, etc. So all this data we bring into a central database, and based on fundamental knowledge of the system, we try and develop these multi-objective control algorithms, which will allow us again to control pumping and aeration cycles to try and trade off the energy side, the emission side, regulatory side, and the infrastructure intensification side, and achieve the best overall performance for wastewater treatment plants. In some early work we have done with them on sludge dewatering using quasi-real-time control of centrifuge systems. So what we don't do is try and change the actual operational parameters from minute to minute. This might be on an hourly basis where we're changing the operation parameters based on both what's coming into the system and actually the quality of what's coming out of the system. We've been able to show an increase in solids concentration for centrifuge systems of about 2%. And this is at, again, a fully functioning wastewater treatment plant, which would result, if we manage to maintain this over the rest of the year, at about €60,000 savings per annum. And actually, one of the key limitations on this will be trying to implement operator-led calibration and maintenance of sensors to ensure that we achieve these types of savings. So other areas that we're looking at the moment, which I think are going to be very important and very, I suppose, data-rich areas, will be climate and forecasting. So one of the key areas that we may be able to improve the capacity of infrastructure, of existing infrastructure to treat, is to actually better forecast what loads are going to look like, both in the short term from day to day, but also in the long term resulting from climate change. And some of the outputs that we can get from that type of data and from trying to forecast and model how our treatment plant will respond to those changing loads will be things, for example, how we can link wastewater treatment plants to the energy grid. This might occur through, for example, the generation of biomethane and hydrogen on wastewater treatment plants and its release and its use on the grid during, for example, times when renewable energy is low. That's as aside to its actual use on site. The other area that's of interest to utilities is this area of demand response. So how we can use data to actually, if we have adequate balancing infrastructure that can balance in wastewater treatment plants upstream of the wastewater treatment plant, we can actually treat wastewater at times where energy costs are low or when the system might otherwise dump renewable energy grid or curtail renewable electricity. So the wastewater treatment utility can actually pick up what would otherwise be curtailed, and in doing that, reduce the costs of operating those systems. But again, there needs to be a lot of data integration between those two systems, which is an area we're working on with colleagues from UCC and UCD and industry, and also an understanding that the infrastructure itself has the capacity to balance those flows upstream. So kind of some of the key questions that we're dealing with in these projects will be what you should measure and how often. So a lot of these data can be measured on a second by second level. And when does it become too data is too much? And when do we also measure data that's really not necessary? The second area, which is really important, is data error and backfilling procedures are necessary. I would say in many of the treatment plants, in some of the data sets, we get up to 60% of the data could be just incorrect. We know it's physically impossible. And so that's something that we really need to get a better handle on, both on site in terms of the operation of these sensors, but also in terms of how we use the data. I think we also need to understand that using a data science approach on its own is not going to work, simply because it doesn't implement, I suppose, our understanding and our engineering knowledge of the system. The data, the black box methods need to work within these actual engineering boundaries that we know are physically possible for the system itself. And that's where process experts are going to be continually necessary, even in a data-rich environment, to actually put the boundaries on these black box and data-led models. Okay, so the final couple of slides would be maybe where we can go for this in the future. So this company, Vortec, is a spin-out company from the university, so I should declare that up front. But basically, in this side, we've actually designed our technology with data in mind. So this is an aeration technology for wastewater treatment plants. And part of our idea around this technology was to develop a technology that could generate data, but also be adaptive and be controlled by that data. And that actually completely changes how we designed the technology itself and how the technology operates. So when you start with that in mind, you can actually come with different and much more effective technology outcomes. When it comes to infrastructure, the same thing applies. If we look at a wastewater treatment plant that is going to be data rich, it can actually, again, change our options when it comes to designing those wastewater treatment plants. I've mentioned things like the demand response before. Also, the questions as to whether we actually need to build new infrastructure can be looked at again, because our existing infrastructure can be intensified. There may be a move towards modular and batch designs for wastewater treatment plants, for example, and also moves to design in links with the energy and electrical systems from the beginning. And some of that work has been very much advanced, for example, in the Aarhus, Denmark, in their rewater facility, which will probably be the leading facility in the world that has implemented some of these design procedures. So some of the opportunities that will come from this in the future will be things like resource recovery. I think wastewater treatment plants, even the naming of them will change in the future. They will now be providers of resources such as energy and nutrient resources such as nitrogen, fertilizers or phosphorus, sorry, into our food systems. We'll see significant improvement in infrastructure efficiency. It will lead to a lot of design, operation, and technology innovation in the future. I think Ireland can gain from that and has industry that can actually leverage those. And given that there is a $7 trillion gap, according to the World Bank, in terms of water infrastructure to be developed to 2030, I think the use of data and simulation will play a key role in enabling this new infrastructure. So there's more information, some high-level information at some of these links, and I'll leave it there. Thanks a
million, Eoin. So again, I suppose the segue between the first presentation, second presentations, it's all about this data-led decisions, I suppose, in there. So in this case, examples of control and operation of wastewater treatment plants, and that data in terms of understanding, in terms of compliance, energy efficiency, or reducing the operational costs and reducing the emissions in there, and also kind of similar vein from Gavin at the start in terms of the importance of considering data at the start, like how data can inform decisions, and that's I suppose only touched on that at the end in terms of having that data in mind when we're designing the infrastructure, and if we actually have the ability to gather data to inform decisions in the operation of our infrastructure later on, then that can be very helpful. So that brings me nicely into Robert Moore. So Robert is the project lead at Build Digital, and he's going to talk about information requirements to drive these simulations of other cases. So Build Digital, set up to try and, I suppose, fast track the digitalization of the sector, the construction sector in Ireland, and he's going to kind of link in together how the data can be brought together in a useful way. So over to you, Robert.
Thanks a million, Jamie, for the introduction. Yeah, no, I just want to do a presentation here about information requirements to drive simulations and other use cases. So I suppose just to give kind of a brief explanation of Build Digital and what our mission is to unite the construction industry and the built environment sector towards an integrated digital adoption across innovation to improve efficiencies, productivity, and international competitive for a sustainable basis in Ireland. So that's really what our mission is across that. And obviously we are also very focused on the BIM mandate as well that has came true in the last number of years to support the industries, particularly clients at the moment, but we will be going down to the supply chain. So just to continue on and look at the presentation, I suppose we're very lucky actually on the way that people came from two views of what information requirements is needed. Like originally we heard about models, we're looking at using models and 3D models around planning application, and then it was very much then looked at a data-driven approach towards what was needed. And I suppose that kind of brings me on to say that, like, sometimes people think that when they have a model, that's all they need, a 3D model. And when they have the 3D model, they can do whatever they need to do with that. And that not always is the case. So I suppose looking at that, when you're prescribing there, you need to prescribe the right information to do what you need to do, and not just assume that you'll ask for a level 2 model or something like that. Use a frame like that, a BIM model, and then you will be able to apply whatever uses you want to that model. No, you need to think about that more specifically, what's needed. And I suppose to come back and look at what building information modeling is, straight back to the definition from the ISO 19650, it's using a digital representation for reliable decision making. So it's very important that there is a use for that, and it's not just you have a 3D model for the sake of a 3D model and you don't know how you're going to use that going forward. So I suppose really to look at use cases requires the right information. And I suppose really to talk about uses and use cases, in a way, the most simple way of looking at these is the dimensions are all our uses of models. You can use the BIM for coordination, scheduling, estimation, sustainability, operations, safety, and lean is probably coming in at 90. So in a way, these are all use cases. So you're using the information for these kind of cases then. And I suppose to really think about this is, like, if you go into a restaurant and just ask for, can I have a breakfast? There's an expectation of what you're going to get. When the server comes out, you don't have any real ability to change the breakfast, and it might not be what you actually expected when you ordered your breakfast. You might have thought that there'd be mushrooms on the breakfast, there might be no beans on the breakfast. You might have wanted to have scrambled egg or poached egg or whatnot. You mightn't have expected pudding, and in areas you could have expected a tomato. So you don't really, you need to be more detailed of what you want and not just leave it by chance to see what you'll get at the end of it. So it's very important that you prescribe exactly what you want at the start of the phase. And look, and to use the example of breakfast, most of them changes could have been done very simply by the kitchen at the start. The egg could have been done whatever way you wanted. But when that information is served up to you at the end, there's very limited ways that it can be changed. And there could be a huge cost effect and a time factor as well. So when you want to look at them. So I suppose it's known about your information requirements. And look, there is some known knowns, which makes it kind of easier for people to prescribe when they're coming as a client to describe what they actually need within it. So I suppose really when you look at it, when you're doing and I always go from the standpoint of a capital works management framework project, that there's a lot of information requirements that's actually known at the start before you actually go into go into the project itself, because you'll be working according to the requirements, policies, and also like the Capital Works Management Framework, which has requirements. Obviously, the safety file also has requirements. And you might have other asset requirements according to ISO 19 to 55,000. So there is other requirements there that should be considered as known knowns, and then you'll progress them through to your organizational information requirement. That will progress down into your asset and project information requirement, and then finally what you'll do is you'll make an exchange information requirement for the exchange of that information to satisfy that requirement. So I suppose there's also, you could say there's also known unknowns as well, and that's where probably simulations can come in to help you with what you're doing, because as a client you mightn't really know how the information will be done, and that's okay, because you can ask for an outcome and don't prescribe a process. Like I suppose in another example, a real world example of this, like if somebody's going to a meeting, really what you're told is where the meeting is and what time it's at, and it's up to yourself to make that journey to the meeting. If you're being invited to a meeting and how they describe it was you go out the door, you go down, you get a bus, you go 5 stops down, you get off, you turn right, you turn left, there's a very good chance you actually won't get the outcome that you want. So sometimes not prescribing the process lets the supply chain innovate to what it's done, and that really feeds back into where some simulations there can be done to actually give some very good uses of the data that's been required and how it can be used. So I suppose just on that, if you have then that you have a use, that the use is set up in the organizational information requirement, and then you will look at how that will be then transferred into exchange information requirements. So just to move on, what I'm going to do is I'm just going to show you some examples of this. So in our Exchange Hub, so if you go into our site and go into our Exchange Hub, and what I'm going to do is I'm just going to filter down to some of the templates we have. So within the templates we have, our organizational information requirement is in there, or our organizational information management template. And if you just click on that, it will download the template for you. But I suppose as to do it, here is one I've prepared earlier for this. So I suppose I spoke to Gavin there during the week, and I just said to Gavin, like, for the product that he's providing, what would be the organizational information requirement? And that actually is a very high level thing, doesn't need to get into any details. And how we've been looking at writing organizational information requirement is around 3 things. It's the person and it's the planner. Need to act, what activity, they need to assess the impact of a new development in the area. And what they want to do is they want to understand how shading and overbearing on existing buildings. And that's the requirement, that's the organizational requirement. And now you could say that organizational requirement, there's many methods that could be used to fulfill that. You could go in, you could say, well, what we're going to do is we're going to do a whole heap of perspective drawings from every window, from every position going around, which is not really appropriate, and it totally overdone it. But to know that you could go in and look at a software, do a simulation like was done there, shown earlier, and that allows you to assess the overbearing from every angle and every position, and also the shadowing as well can be done quite easily. So it's about not prescribing that in a very early stage, and then just go back to where we were, and then I suppose that's just an example of our organizational information requirements as explained. And then I suppose to move on to the appointed party information exchange, that also going to be downloaded the same way, and that has an exchange information requirement within it. And then just to look at the exchange information requirement, just to go, all these things can be downloaded from our Exchange Hub. So if you go into the Exchange Hub, right, okay, and then you can find the template here, and then from the template you can just go in here. So this is how you can download our templates. And a quick look at excuse me, to go back, here is the organizational information requirements according to what was needed for Gavin's presentation. It's a planner, The planner will need to assess the impact of a new development in the area, and the purpose for that is to understand shadowing and overbearing of existing buildings. So the organizational information requirement is actually quite easy and quite light, fairly easy to see. So I'll move on, and then I'll move into the organizational information requirement. And what that is, it's stepping down the requirements for what is needed to be exchanged now. So from that organizational information requirement, they'll went through the process and they'll understand that there's a tool there outside that simulation is the way to go. And now what it's about is asking for them information requirements so that simulation can be done. Because I suppose just to expect that you have the right information from your supply chain is an assumption that can lead to that it's not there. So I suppose really what we wanted to do was provide assistance to assess a planning application in the context of the local area model. And within this, so I suppose it's the information requirement description, the level of detail needed. So it's only the external skins of the buildings that's needed, and it does no need for internal modeling or anything like that. The model is developed to LOD3, and then also the demolitions is on a new layer, and the new building is on a new layer, and does other requirements around that. So that's the level of detail. And the acceptance criteria, it's around the type of files that's needed. So DWFX, using SY and Z coordinates, the LOD3 according to the city definition, and these are the formats that's accepted. And then some supporting information is, so basically what would happen is you'll get a tile out for this to know how you'd locate the building according to other buildings, and also does the definition of LOD3, what the LOD left definitions, it prescribes that according to the city GML definitions, and also the frequency of that is on the planning application. So that goes through the information, the 5 areas of the information requirement of how that's done and what information is needed. So I'll just go back into presentation again and finish it off there. So I suppose to look at then of our takeaways then on what it is, the 3D model might not be everything that you need. So you need to prescribe what information you need. And as for the other, it might not be a model that you need. It might be actual data. So that it might be just raw data is what you need. And there's no requirement for a 3D model. So I suppose just don't think because you have a 3D model, all aspects is covered. And I suppose it's also known your uses and only include for information that you know you need. And I think that's a very important thing that sometimes people say, well, look, we think we might need this. And that makes the supply chain a large amount of requirements that they need to deliver. So it's very important that it's focused on what you need at this current moment. If you discover you need it, you just get it in the next project. It's about the best way to do that. And allow your supply chain to innovate as well, to allow them to innovate what they need, and then also Build Digital have templates to help define information requirements for use cases as well. So there is a lot on our Exchange website. So I'd advise you just to have a look through it and see what you can find there. And I suppose that just finishes off my presentation. Just one last thing is I'd just like to encourage everybody. Currently, we have our annual survey released at the moment. And look, if I would encourage people to finish it. It's closing in fairly soon now. So just if you want to get on it, you log into it. So if you can't complete it on one sitting, you can get back in and they'll pick back up exactly where you are.
Brilliant. Thanks, Robert. That was great. So, great link in to show how, from Gavin's example there, how you would develop your organization information requirement and your exchange information requirement meets the ISO standard for building information modeling, which is required obviously for delivery now of large infrastructure projects in Ireland.